Good morning, everyone. Today we're going to be going over Intro to Python Object-Oriented Programming. Now, up to this point, we've been learning about procedural programming, which means you're writing everything in functions. But moving forward, we're going to start utilizing classes to write all of our program. Well, what are classes? And what is object-oriented programming? Let's start talking about that. So, an overview today, we're going to talk about an intro to object-oriented programming. What are classes? We're going to go over how to instantiate an object with the init method and what is self. We'll then talk about instance methods, and we'll dive into dunder methods. Now, all this information is going to be tested during assessment 1, which will be happening at the end of this week. Perfect. Does anyone have any questions over what we'll be covering today and how you'll be assessed?
Could you take us back to that last slide for my notes?
Absolutely.
So you said instance methods was the term to refer to init and self?
Yes.
Instance method.
For init, that's going to be an instance method. We'll be
Oh,
covering self separately.
and self is a different thing. Okay, instance methods and then self is another thing.
Right.
Okay, we're good.
Awesome.
Question about you said how the assessment would go. Was that covered already before? I don't remember.
In regards to assessment, we talked about it on Friday when we released the practice assessment, but we can definitely do another overview over how assessments work later on today if you need one.
Oh,
Great.
I guess last thing, and this might be not worth any your time, but what would the difference between functional programming and procedural programming be?
So functional and procedural are the same thing. They're hand in hand.
Okay, they're
Yeah,
the same thing. Okay.
correct. All right. Awesome. Let's move into our slide deck then. Can somebody read this paragraph, please?
Object-oriented programming, or OOP, is a programming approach that organizes code around objects, which are representations of real-world entities. It focuses on breaking down complex problems into smaller, manageable pieces called classes that have properties, also called attributes, and behaviors, called methods. By using OOP, we can create a reusable code, promote code organization, and simplify problem solving by modeling the relationship between objects.
All right, awesome. So just as previously, or just as mentioned here in this slide deck, all OOP is the reference to real life nouns. That's the way I like to represent it, is a noun is essentially represented by a class, where a noun has characteristics or attributes, also known as properties, and a noun may conduct certain actions, which we'll know as methods. Now, what is a class in Python? In object-oriented programming, Python classes are blueprints or templates that define the structure and behavior of an object. Classes encapsulate data, attributes, and functions, which are methods, that operate on that data, allowing for modular and organized code. So here's where we're really going to start diving into the concept of dry, which stands for don't repeat yourself. What we're utilizing here for classes, which we'll see here in code shortly, right now we're just understanding the overall concept, is we're trying to stop ourselves from rewriting code over and over again. So here we have an example of a blueprint of an iPhone. Now, let's say we wanted to write what an iPhone is as a dictionary. We would have to continuously rewrite over and over every time a new iPhone is created, how that iPhone is represented, all its key and value pairs, all of the different actions that an iPhone may be able to conduct. We would have to redefine it every single time a new one comes through that assembly line. Well, by utilizing classes, instead of redefining it all over again, we can create a blueprint that we know all of them are going to follow. So every single time we need to create an iPhone, rather than rewriting the entire code structure to write a new one or copying and pasting and occupying lines of code, we just simply need to feed it through a constructor to be able to build our new iPhone. And we'll go over that here shortly. All right, so this is class versus an instance. All right, so our class, which is our declaration of a class, our blueprint is there on the left-hand side. And the instance of a class, meaning an actual object has been created and saved inside of your computer memory, is something that comes from said blueprint once all the properties and methods are processed. So something actionable that you can interact with. Whereas your class is just a blueprint that's made to make sure that we're continuously making good instances. All right, does anyone have any questions over these two separate slides there? So a class and an instance. All right, perfect. In that case, let's start talking about the pillars of OOP. We have encapsulation, abstraction, inheritance, and polymorphism. Now, typically when you step into an interview, they're always going to ask you what are the four pillars of OOP. In the off chance that they ask you what are the five pillars of OOP, know that the fifth pillar is known as composition. We will be teaching it here in Code Platoon. We will be teaching you how it works and what it does. Majority of the time, they'll ask for the four pillars. In the case that they ask for a fifth, know that the fifth is composition. And I see a hand up. Go ahead, Justin.
Do you have any good acronyms or mnemonic devices for us for learning these pillars?
Ooh, that's a good one. I don't, but I can definitely find one.
I would appreciate that.
Awesome. All right. Let's go ahead and push forward here. So encapsulation and abstraction. Encapsulation, so specific data can be restricted from the rest of your code. And abstraction is logic complexity hidden for simplicity. So encapsulation, specific data can be restricted from the rest of your code. Well, that means that my phone has its own behavior, right? It doesn't interact with the behavior of other phones. So there's no global variables that I'm interacting with to keep some sort of record of all the logs or phone calls that my phone sends out. Every single phone has their own call log that tells them their own record of how many calls have been sent, when they were made, when they were ended, and so on, right? So if I have multiple phones inside of one script, the data is being encapsulated for each one of those phones. Now, abstraction, the logic and complexity is hidden for simplicity. If every single time a user had to make a phone call, they had to actually look at the code, operate everything that's working under the hood within the phone to be able to connect to a phone line and send their actual phone call, it would make the phone almost unusable, right? Or it would defeat the entire purpose of even having a cellular device. So instead, we hide all that logic and complexity, and we just give the user a nice user interface. All they have to do is click a couple of buttons, and the phone runs everything under the hood without the user actually seeing it happen. So that's abstraction. All right, any questions over encapsulation and abstraction?
Yes, for encapsulation, you're talking about within the data or within the code, right? That there is code that isn't used by the other parts of the code, like scope, I guess.
So in reference to like global and local scope, that's one way to look at it.
But for abstraction, is the logic and complexity hidden for the people that look at the code, or is it just outside of it after the thing's produced?
It's outside after the thing's produced, not for the
Okay.
people who look at the code. That's a great question. All right. Now, inheritance and polymorphism. So inheritance, sharing of similar features and attributes. And polymorphism is objects can take different forms depending on their needs. So inheritance, we have, iPhone, I think is or one of the most recent examples and one that everybody here can relate to. We see a new iPhone come out every 2 to 3 years, right? And there is very little changes that are made to the iPhone. Now, I use this as a term of inheritance because there's the original blueprint that was made for the very first iPhone. And then after that, rather than restarting, throwing that blueprint out and starting from scratch, you could grab the same blueprint and add a couple of new features, add a couple of new attributes. And now, whenever you get the materials, you have a completely new series of iPhones, right? Two separate blueprints, one for the original iPhone, the second for the new one, but the second one is a child from the original blueprint, right? We're just essentially adding to that original blueprint. That's the concept of inheritance. Now, the concept of polymorphism is we can take a look at, for example, here we have Maps and Google Maps, right? Both of them accomplish the same exact thing. Now, Google Maps was created before Maps, right? So Google Maps can be our original template, we take the navigation from Google Maps and make it more efficient. It's still working to accomplish the same goal, but it's changed or tweaked to be able to fit our new product. So that's where polymorphism comes in. All right, so that's inheritance and polymorphism. Does anyone have any questions over those two? We're going to be diving into these more in depth throughout the week as well. This is just a quick introduction.
What was the fifth one again?
Composition.
Composition. Thanks.
All right. So if there aren't any questions, before we start taking a look at getters and setters, I'm going to save this portion of the slide deck for the very end. Let's actually start talking about what we'll be doing today and start seeing some code. So this is our end state. And let me show us our drawing first before we start looking at the end state of the code. So here in our drawing, what we're going to do is we're going to make a class declaration. That class declaration is going to be our outline to create a dog. Now, within our class declaration, we're going to create some sort of method that will help us or allow us create more and more dogs without us having to hard code it or repeat ourselves whenever we're creating dogs for our dog shelter, right? We will provide properties to this method. That method will create a dog for us. And we're going to give our dog, other than its attributes, we'll also give it some actions, such as barking or fetching an item, which are going to be our instance methods. Now, if we take a look at this in code and try to do a little bit of relations here. And I apologize, Andy, give me a second. Let me go ahead and cover this real quick, and then we'll start opening up for questions. If we take a look at relations, here is our class declaration of a dog. The method that will be creating all of our class instances is also known as the init method. There you can see that it takes in some properties and it assigns those properties to our class. Here you can see that we have our two methods. We have a method where our dog will be able to speak. And we have a method where our dog will be able to fetch an item. Now we actually put everything into practice. At the very bottom of our script, we're able to call our class method to create a dog. This gives us dog back into my dog. In this case, this dog is named Apollo, so we'll reference to him as such. So Apollo becomes created here on line 32, where we actually provide different properties into our init method to create our class instance. We're able to call the actions of the dog, see the dog's properties, and change some of the dog properties as well. And if we run this in the terminal now, you'll see we get woof. That's going to be their speak or their barking. We get Apollo, which is their name. We're able to change that dog's name. And then we can even see the dog's string representation happening down here. So this is going to be the end state and what we'll be working for towards this class. Now let me go ahead and open it up for questions. Go ahead, Andy.
On that little the image, would you be able to kind of pinpoint which pillars define which portion of the, I guess, the whole process of class or OOP?
Got it. Not within the image. I can definitely point that out as we're working through the code. Now do that here during the lecture. Dallas?
Can you zoom out on the picture so I can see the both machine sets? Okay, so on the right, instance method action is, I think, simpler. I can grasp that, but init method to create an instance of the class. Uh, how does that differ? Since that's an instance method as well, right?
Hey, it is not. So this method actually belongs. Oh, wrong pencil. Let me try that again. This method actually belongs to the class. And that's why this arrow is moving back and forth between those two. So the method belongs to the class, and it's to help it be able to create instances of said class. We're going to be diving into class versus instance methods here shortly. And by shortly, I mean by tomorrow.
Okay. Is there would it be fine to just call it a sub method then when you get to the point of instance, or like a sub function, a function within a function?
Um, I think it's going to make a lot more sense once we start seeing it in code, and I'll make sure to emphasize it. I think, well, let me pause on this question, and then once we start working through it, it will make more sense. If you still have a question, then just let me know and we can go back over it. Does that work?
Gotcha. Yep. Yep.
Perfect. All right, timer.
Just to follow up on Dallas's question, is init like Python's constructor method for a class?
It is, yes,
Okay. Okay, thanks.
of course. All right. So let's dive into, oh, hello. Let's dive into actually creating this class first of all. Right? So as previously mentioned, what we want to do here is we want to actually be able to create a dog. Now, in order to create this dog, what I need is to have some sort of class declaration. Now, I could create something like my dog and then have it have different objects where I can tell it where name is, maybe I make a function that says create dog, right? And this function could take in things like name, it could take in things like height, breed, weight. And I do name is name. Apparently I'm forgetting how to code. I apologize, everybody. Got to bust some good old Monday rust. We have some height, which we could then know as height. We have the breed, which we can then know as breed, and the weight, which we can also get to know as weight. Now let's say that I want to have this dog have some actions. I want this dog to be able to speak. How would I create a function that would print into my terminal some sort of sound? How can I do that?
It wouldn't be lambda, would it?
Okay, so I could create a lambda function. And what is it going to do? Print sound, right? Where does sound come from? Would that have to be a new attribute that gets passed into this function, or a new parameter that gets passed into this function altogether?
I mean, that's my thinking.
Yeah, so let's add it in there, right? We can go ahead and put something like sound. Now sound can be referenced to. Let's say speak. We'll take this lambda function here. And then instead we'll just call speak sound. All right, just like that. All right, so there's my dog. My dog's able to speak. He has an action, and he has some attributes made to him. Well, finally, I will just return my dog. right? This is how we've been doing our programming up to this point, where we can actually create a dog utilizing some sort of key value pairs. But is this very efficient? And if something about my dog property changes, let's say that now, not only do I want to keep track of this, but I have to keep track of color. Well, let's go into creating a couple of dogs here. Let's say dog one. Here we'll go ahead and do create dog. We pass in a polo. We pass in a breed. Let's say pit bull. Let's say, oh, we need height,
Yeah.
which let's say 2 for now, and then that gets interpreted as feet. Let's say that the weight now is 120 pounds. And let's say the sound is woof. Right? And we're going to creating a couple of different dogs. All right, well, now we've created a couple of different dogs. And I'm utilizing these dogs in multiple scripts, right? Well, what happens if I decide that I also need to be tracking a new attribute inside of my dog? What would I do now? Well, I would come back here and maybe add something like color. Hey, I want to be tracking the color of this information. And I add it into my function builder. But now what's going to happen to all of these methods down here?
You need to add it.
Right, I need to add it, but it would also break my code if this were to happen while my code is running, right?
You missed
Or
a
if I were
comma.
to, oh, thank you. Or if I were to change anything within my code overall. So this isn't a very dynamic way of writing a representation of nouns, nor is it a good way of stopping us from having to repeat ourselves, right? We would have to backtrack and find exactly where all of our changes came from in order to actually update our entire function for being able to create a dog. So instead, what we do is we have classes. So let's start off with a simple class declaration of a dog. This is all I'm going to start off as. And now let's go ahead and do my dog and make that equal to a dog instance. Now if I go into printing my dog, let's take a look at what happens inside of my terminal here. Here I'm getting, hey, inside of the main script, there's a class named dog. So this is my main script. There is now a class named dog, and it tells me we have an instance of that dog at the following memory location inside of my machine. That's all this little line of code is doing. So now I've been able to create a dog, and I see there's a question, so I'm going to take a pause here. Go ahead, Michael.
Do you need the parentheses in the class dog? And if it's even like usable, what would you use it for?
You do not need the parentheses in the class dog. You're referencing to line 17. I do not need that parentheses unless I'm utilizing inheritance, which we'll go over later on.
Okay, thanks.
All right. So now I have my dog. I've been able to create an instance of my dog. But currently my dog doesn't have any properties or attributes. Well, I could do something like this. I could say, hey, my dog.name is equal to Apollo. And now I can do name. And I can get Apollo being returned. But notice that when I do it this way, it's not really recognizing that it's an attribute of the class, even after I wrote it. And this is going to be a pain if I were to do every single line one by one to include maybe something like my dog.age is equal to 3, and so on. So there's got to be a better way to actually be able to take in all of these attributes. Excuse me, everyone. Well, that's where our constructor comes in, or a init method. Go ahead, Cody.
The way you just did it without creating the init method inside the class, will Python automatically create that method and then append those attributes to it?
I don't know what you mean by automatically create a method, but it will append those
So
attributes into it.
yeah, because you just had class dog pass, and at the bottom, yeah. So you have no init method inside of your class, but you are appending attributes to it. So is Python behind the scene creating that init and appending those attributes, or
Right.
because
So
usually you do the init and you would do self dot name equals Apollo and so on, but you didn't do that. So is Python doing it automatically?
it is, yes.
Okay.
So this class dog is our blueprint, right? Here at my dog, what I did is I copied and pasted that blueprint and said, okay, well, now I actually want an instance of it. So now there's an actual construction of it. I didn't have any attributes to it, but by doing this dot name and dot age, both of them automatically got added into that instance of the class. All right, Justin?
Just for my brain's sake, could you show could you give us a actual representation and code of what this dog class looks like over time, like from initialization and then as you keep appending these new classes? Is that too much work?
Sorry, could you say that one more time? I think
Like
I
with
might have
more
missed.
dogs, do you mean?
No, I mean, so you create this dog class and then it's just this blank slate, right? And then as you keep adding these new attributes, they should be populating under that dog class, right?
Right.
What does that look like in the back end, I guess?
Oh, okay. Got it. So something similar to this.
Because even Cody mentioned that the the init dunder method should like pop up right as you're doing it as well.
Yeah. So what we're doing here is, again, we have our class declaration, right? So our class declaration of a dog, we don't know what dog or what this dog will have. As of now, this dog has no properties, no attributes, nothing inside of it. When in line 20, when I have my dog, well, that's when I take in this dog and I actually create an instance of it. It becomes solid at that point. In line 21, currently there's no initializer, there's no attributes, there's no methods, so it's not really working the way I want it to. So in lines 21 and below, that's where I'm manually adding one at a time and saying, hey, now you have a name, which is a key value pair that stands for Apollo. And then I'm saying, now you have an H, which is
Okay,
also a key value pair, which stands for
so this isn't affecting the class whatsoever. It's only affecting the instances of the class. Then
exactly.
it's not in it. It's not copying these attributes as well to the class instance, the class itself. It's just doing it on the instance.
Exactly. Which I think that was, I apologize, Cody. Was that your original question?
That makes sense. I was just mainly like wondering, like you didn't build the init method inside. So I was wondering, like, if you don't include that, does it self build it as you're adding attributes to the instance?
Got it. It only does it to the instance, not to the
Yeah.
class.
Yeah, it makes sense to me now.
Awesome.
So that would be a demonstration of the encapsulation, right?
Yes. All right, Dallas.
So does this mean that by skipping the class dog, you're just passing it and making it yourself? You're creating the dog without a blueprint every time?
So as of now, the blueprint is just this portion, line
Right.
17, but it has nothing inside of it. So I could create many dogs, but every single time I create a dog,
Do
that
by
dog
hand every time.
has no attributes inside of it and no actions. Does that make sense?
Yes. Like so you're, like you said, for the assembly line, where if you don't have the blueprint, you have to make the phone each time that it goes through. You have to design the blueprint again, again, and again. Is that what's happening here? Without having that blueprint filled with info?
Got it. On lines 21 and 22, is that what you're referencing to?
Yes, and 20, I guess, but I'm not sure about that.
Yeah, so 20 is what actually makes the solid instance of a dog. And then in lines 21 and 22, that's where I'm telling it, hey, this is what you're going to do with the following properties. Because my blueprint didn't account for those properties. So I'm manually telling it what to do. But we're going to cover how to change this behavior here shortly so that every single instance knows what to do with these attributes.
Okay.
Andy?
Yeah, just wondering because it's interesting that it doesn't spit out like an error because it's like not name and age is not part of class, you know. So I was just interested in how does it go around that?
Yeah, so what it's actually doing, it's doing an assignment process here. So even though it doesn't recognize it, it's giving me the availability and it's a flexibility within Python that essentially says, okay, well, if you didn't tell me how to handle some sort of um, subject or you want to add something into one specific instance of a class, but not to the rest of them, you could utilize variable assignments where just as if I were to reference a dictionary and add a new key value pair, well, now I'm referencing a class and adding a new property with a value to it. Does that make sense, Andy?
Okay, so you kind of like preposition like my dog, and then you tell it here's a new variable and assign it a poly to it.
Yes.
Okay.
All right. So now that we just covered that, we just essentially learned that this isn't very efficient, right? And it's not working as expected. So instead, I want to change the behavior of my blueprint to be able to handle this init method, right? And I wanted to know what attributes are already within it. So let's start adding some attributes to our blueprint here. I could do something like as follows, right? I could say, all right, well, now I'm going to create my initializer. So this is our init method that we're working on. Notice that I am defining a function and I am utilizing a keyword named init. Now, this is a keyword that belongs to a class, and it knows that its purpose is to initialize purpose of the init method is to grab arguments and assign them to class properties in order to create an instance of the class. So it's initializing an instance of the class. Well, now for this init method, we need to talk about a couple of things. Oh, and I see a hand. Go ahead, Justin.
Okay, so am I to understand that these instances of the class are not getting these init methods automatically because the purpose of the init is to create instances, right?
I see what you mean. So will they have access to the init method from within the class?
Right. So which would affect any classes that you might grab from these things, any sub classes of these dog instances, like would not be able to grab these same methods, I guess.
Yeah, so if we wanted to talk about, well, I don't want to dive too far into class versus instance, but to answer your question, that's correct, right?
Okay.
So our init method is wrapped within our class, and the only way it can be accessed is by the class, whereas instance methods can be accessed by the instance.
Okay. Okay, so the init method is required to give other things methods. And that's why it's not necessary for the creation of these instances because we are just manually inserting these attributes. Is that correct?
Which we did later on. Yes, that's correct.
Okay, so it never gets the init method. It's not anything that populates within that class. We just don't need it
You
because
can
we're doing it
reference
by
it.
hand.
Yeah, you can reference it and it will exist within the class instance, but you can't call it or utilize it.
Are you talking about the init method or are you talking about the attribute?
I'm talking about the init method. So the init method will still under the hood live in here or have a
Okay.
representation of it in here, but you can't utilize it. Its existence is just there.
Okay, but we can't call it because we never created it
Exactly.
within our code. Okay, thank you.
Of course. And I saw a couple of hands go up. I lost him. Nick?
Isn't the init method just a default set of instructions every time you try to instantiate a class that runs automatically? So when you call class dog, everything in init will run as long as it's set up properly, right? It's like an
So
initialization, a startup.
yeah, exactly. So let me go ahead and write it out in code for everybody because I think once we see everything in code and start building out the building blocks, things will make sense. It looks like I'm answering a lot of questions that might be answered by us just seeing it in action. So let me close down a code block and then afterwards I'll pause and we'll go back to answering questions. All right. So now here we have our init method, which we know its entire purpose is to initiate or to start an instance of the class. Now, how do I know that this is referencing an instance of the class, or how can I assign attributes to them, right? If I just do something like name is equal to name, well, this is actually going to cause some sort of failure if I were to pass in name straight in here, because it doesn't know who it's talking to. It needs a representation for the instance. And this is where self comes in. So the very first argument that you're going to pass into anything or any method that is built for a class, it's going to be self. Now, self, it quite literally is referencing the class itself. All right, so the init method is happening. We're saying, hey, I am building self, which is a class of dog, and I need the following parameters. I need to know the name of a dog. I need to know the color of a dog, the breed of a dog, and I need to know the sound of a dog. Well, again, name, as of right now, doesn't belong to a class instance. Well, how do I make it belong to the class instance itself? Well, I add self. So I'm saying within the instance of this class of dog, I am assigning now an attribute. So now instead of saying my dog.name, I am saying self.name is equal to the parameter name that gets passed in. I'm saying self.color is equal to the parameter color. Self.breed is equal to the parameter of breed. And then self.sound is equal to sound that gets passed in. All right, so I no longer need these three lines here because these two lines are now happening in here. Now let's go ahead and create an instance of our dog. I have my dog, which has Apollo being passed into it, right? And it's notice that it's matching the order that we have here. So the next thing that we would have would be the color, brown. The next one will be bulldog. And the last one will be wolf. Right? So there's our different attributes or properties that we're passing into the init method. And as a result, we'll have our dog. So now if I go into printing my dog, you'll see that not much has changed there. If I run Python dog, we pretty much get that exact memory address. But now if I go into name, well, it's able to recognize that name is an attribute, or excuse me, a property that belongs to the class of dog. If I change this and go into the sound of Apollo, it's still able to bring back the correct value for said property. So just a quick recap, what we did here is we created a method that will handle all of the properties that come in. It needs to know what it's assigning it to, and that's where the keyword of self comes in. Right? So self tells it, I am creating an instance of the class of dog. And this is the very first parameter. And self gets passed to dog down here. And we know that that gets assigned to my dog. We'll break down self a little bit more here shortly, but I do want to answer questions first. Go ahead, Daniel.
For the print statement, could you typecast list and it'll list out all of the attributes without having to access them using?
No, we're gonna go over how to see a readable information regarding this class here shortly, but we're not just there yet. All right. Any other questions? Okay, so let's dive into self. What self stands for here? Self is just a placeholder. If we wanted to change this naming convention and know that the reason why we're utilizing this placeholder is because that's what's common, right? That's the Python standard is to utilize self. But you could definitely change this to X. You could change this to a bunch of gibberish, and everything would still work. So why choose the keyword self? Well, that's because it's easily readable, and what it tells us that what it's referencing is the class itself. Right? We know that this self is referencing to the class, and we're assigning attributes to the instance of the class, or properties, excuse me, to the instance of the class. So if I were to go and create another dog, I call this one my dog 2. And my dog 3. And I go to change some information regarding my dog 2, say dot color is now black. And I print my dog 2 dot color. We could see that the only change, or the change, oh, excuse me, of those variables only happened within my dog 2, right? Everything is isolated. This is a form of encapsulation to its own independent instance. So what that looks like now is now within this drawing here, well, now I have an init method. And what this init method does is it knows it's going to receive a name, or that it needs a name. It knows it's going to need a color. It knows it's going to need a sound. And it knows it's going to need a breed. And every single time that one of these instances are created, well, now they have an assignment that says, hey, you have a name. And that name is Apollo. You also have a color, and that color is brown. And so on. For lack of time, I'm just gonna stop here. And every time one of these instances is created now, it is created with the appropriate properties. Because my init method inside of my blueprint is aware that this is the values that it is going to need. All right, and I see a hand up. Go ahead, Michael.
What happens if a value isn't assigned to one of the init methods?
Yeah, let's talk about that here. So now that I've declared an init method, and I'm telling it, hey, in order to effectively be able to create an instance of this class, I need you to have the following arguments being assigned. Well, what happens if one of them's missing? Let's say I'm missing wolf, which is our very last one. If I go to try to create a class now, well, now I get an error. And it's telling me, hey, I'm missing one positional argument that is required, and that positional argument is sound. All right, well, let's bring sound back. And instead, I'm just going to remove bulldog. Now let me run it. I still get the same error, but I know that the sound that I want to provide is there. Why am I still getting the same error?
Because you're missing the last argument.
Yeah, I'm missing the last argument, right?
Just read it in order.
Yeah, it's just reading it from left to right and assigning it as follows. So as of now, wolf would be my breed. So because I created an initializer, my program now knows that it needs every single one of these parameters to be able to create a class. Well, now what if we wanted to make a parameter optional? What if we didn't need something like, hey, honestly, I really don't need to know what sound a dog makes, because obviously the sound that it's going to make is something like a barking noise. Well, I can specify that sound can be equal to none. Oh, I'm never getting the syntax here.
Is it just an equal?
Yeah, I think it's just an equal
Yeah,
sign.
that's what it is.
Yeah,
It's
to
just
give
an
it a default value.
Yeah, thank you. All right. And by doing this, I'm essentially saying, hey, the default value of sound is none. So if something is not provided, just assign it to none. So now we take off the sound that we provided. And let's take a look at this sound. So now a parameter is still being accepted here, right? I don't want to give the illusion that this means that there's no longer sound being introduced here, because it is. I'm giving it the value of none within the initializer so that it can be placed inside of self.sound. But I can still pass something like wolf. And in doing so, instead of utilizing none, it accepts sound. I am giving it a default value so that in case I don't get something, so let me do this. In case no sound is provided, assign sound to none. All right, Alex.
So if you had like a default name in there, and then you wanted to, or maybe you had a default for breed and sound, when you passed in parameters and you wanted to just use the default breed, but you wanted a specific sound, would you have to put in a placeholder for that parameter to reach sound, like to get around breed, and what would that parameter be?
Yeah, let's go again. So now I want to actually pass a default sound, but we just went over the fact that what's going on here inside of Python whenever we're building this is it assigns it directly, right? So if I wanted to provide a default sound, but not a breed, let's take a look at what we can do. I'm going to go ahead and remove this information and then run it. Well, that's still giving me none. And that's what we expect. As of right now, what it's tracking is that my breed would be equal to woof. Well, what I can do is specify, hey, the sound argument, when I pass it in, will be equal to woof. And now when I execute it, we can see that it gets assigned appropriately. And if I run this here to the breed, we can see that we get GSD, which is the default value that we have provided. All right. If you are specifying default values, they must be to the right-hand side of your parameters. If you place it on the left-hand side and then try to assign values that don't have default, it's going to throw an error. Let me do a quick demonstration of that before I start answering questions here. I'm just going to take sound here because that's the one we're specifying. And I'm going to place it right over here. Well, you can see that it's already telling me an error, and it says non-default argument is following a default argument. Python doesn't like that. It's going to tell me that I have a syntax error altogether. So just keep that in mind whenever you're doing, if you're assigning default values must be assigned towards the right of the function parameters. If it gets placed before any of the ones that don't have a default value, it's going to throw an error. All right, now I saw a couple of hands go up and they all disappeared. So let me open it up for questions.
If you were to not know the key name, so like for that last part where you put sound is equal to wolf, can you just pass in an extra comma? So it'd be like brown, comma, and then wolf.
Yeah, let's try that out. Well, if I do something like that, it's going to throw an error. Because it's saying, hey, you're telling me that I'm supposed to expect something in here, but you're not actually passing anything in. So it's giving me a syntax error. If I try to execute this code, it can tell me, hey, can't do that. There needs to be some sort of value in here. All right. Any other questions?
So earlier on, I think it was the first day or two, we used underscore as kind of a placeholder for like a value that we don't really care about. Um, is that just kind of what was the reason for that? And can we use it here? So instead of doing comma, blank, comma, can we do comma, underscore, comma?
So that underscore was for declaring a variable that we don't care about, not for giving value to a variable, right? So what we're doing here is we're giving value. If I try to pass the underscore, it's going to throw an error. And if I place it within quotation marks, it would work, but then the breed would just be an underscore.
Gotcha. Thank you.
Of course. All right. Timer?
What if you passed in like a empty white space, like just the parentheses or the quotations with nothing in it? Would that
Yeah,
work?
it would work, but then our breed would just be empty quotations. There wouldn't be a breed because we're still passing in a value, so it's overriding that breed.
Okay, gotcha. Thanks.
Of course. All right, so there's our classroom declaration or our class declaration. Now that we know our class declaration, let's get a little bit fancy. Let's start adding some actions to this dog. Well, I want this dog to be able to speak. So I would define a method named speak, kind of like I did with that dictionary example up above. The very first argument or the very first parameter that I pass into any class method will always be self. And all this is going to do is it's going to return an F string, which is going to have the sound. Notice that if I do sound, this is throwing an error. So how can I access the sound property inside of this function?
Self.sound.
Nice. Self.sound. So let's explain that really quick. We know that self is the reference to the class or the instance itself. So it's saying, hey, I already set all these attributes. So they exist. But in order to access them, I have to reference the class itself and grab the sound. All right. And let's build a fetch. So here I'm going to go ahead and fetch, again, self. I'm going to pass in an item. But this is going to return, it's going to be an F string stating, hey, Apollo, so name, has fetched the, and then pass in item. Now, item is in scope with the function itself. So I don't need to say self.item. It's accessible, right? Name is a property that belongs to the class instance. So I have to say self class instance dot name has fetched the item. Let's take a look at both of these. Now, when I execute them, you'll see speak, and let me add maybe an exclamation mark there. So that says woof, as expected. And then for fetch, we get Apollo has fetched the stick. All right, let me open it up for questions. Michael.
In the excuse me, in the case of like line 30, speak self, and line 33, fetch self, comma item, what is the self parameter doing there? Is it allowing it to access the self items in the initialize method?
Yeah, so every time you call the class or you initialize the class or you're calling a function, even though you're not passing anything in here, what's getting passed is the class itself. Right? So the function, visually, it's not taking in any parameters. But every single time you call a method that belongs to a class, the very first thing that gets passed in there, whether we see it or not, is the class my dog.
Hmm.
So self is what gives us access to my dog dot sound, right? If I had another dog, let me go ahead and make a different one here. And let me just name this one Zeus, so that we just, and let me make it, why not? What? Oh, probably need some variable reassignment there. Let's see. If I were to run this, you'll see that it's able to return the appropriate outputs there, right? So speak, wolf belongs to Apollo. So it passes the class of my dog in, and it grabs the sound of woof. Right? And it tells me, hey, Apollo has fetched an item. Well, again, the class gets passed into fetch. That's how we reference self. Self or my dog dot name, that's grabbing me Apollo, has fetched the item. An item is just a parameter that gets passed in here, which in this case is stick.
Gotcha. Thank you.
Of course. All right. Any other questions? Okay, great. Well, now we were able to create some methods. And earlier, I believe Daniel asked me, well, hey, when I go to print the actual representation of the class, I'm not really getting anything. If I just print my dog inside of my terminal, I'm getting a memory space. This isn't readable. There was a mention about typecasting, and that doesn't necessarily work either. Well, Python has given us access to something called a dunder method. In this case, the string method, which again can access self. And what the string method does is it builds a representation of the class in string, right? So now I can go ahead and say, hey, self, or I can tell it to return a string such as self.name is a self.color, self.breed. And now when I go to print my dog, I get Apollo's a brown GSD. And if I go to print my dog 2, I get Zeus is a black GSD. All right. Notice that we added different methods to our blueprint. We added a method of speak, and we added a method of fetch, which takes in an item. Now, both of these methods live inside of every instance. It was created in one place, but the method is replicated at every instance of a dog that is created. All right, this is going to be our pausing point for the first portion of our lecture. Does anyone have any questions over what I've covered up to this point? Let's hear it, Dallas.
I think I have a few. So for the dunder string method, is that the quickest way you can print off the entire thing, where you specify each part that you want, or if you wanted all of them, could you do it in a faster way, like just printing a dictionary would be?
Not to my knowledge. I can look it up. I believe there might be an easier way to just see like the properties, which I think is what you're mentioning, right? Like if I just wanted
Yeah,
to
I
see the
think Daniel was
properties
kind of
inside of
talking
it.
about that. Yeah,
Yeah, let me look it up and then I'll get an answer for us for part 2.
sure. If you can zoom out on the picture.
I'm
Let's see. So I think I get this part, but I want to make sure for the init method. Do you only use one init method for one class instance?
Yes.
Can you have uh, can you have two class instances for one init method, or is it only one to one?
So currently we have 2 separate instances, right? We have instance 1 and
Um,
instance 2.
Init methods. I mean, I don't remember what I said, but
Oh,
can
okay.
you have two class instances from one init method?
You
No,
can't have
I'm
multiple
asking
init
a different
methods.
thing. I'm asking a different thing. I don't know how to say it though.
Okay.
Also, is the init method considered a dunder method since it has that same format?
I don't want to say yes. Let me look that up and then I'll get back to you as far as terminology. I don't want to feed you the wrong things.
Okay.
Internet says yes, for what it's
Easy
worth.
peasy.
What
All
was the
right.
question?
Is the init function there also called dunder?
Oh yeah, double underscore is
The
what
dunders.
dunder means. So if it has two underscores next to each other, it's a dunder method.
Easy peasy.
Roger.
All right,
Yes.
Justin, I saw you speaking earlier. Was there a question that you wanted to point out?
No, that was me stubbing my toe.
Oh, I'm sorry to hear that. All right. Any other questions?
As far as seeing the object in a prettier way, there's another. I just looked up dunder methods in Python. It says underscore underscore get item underscore underscore self comma key. It's supposed to enable indexing and slicing of the object using a list or using brackets.
I had actually a question regarding there's the string dunder method, and then there's the REPR represent dunder method, and I was wondering what the difference between the two of those was, but
Got it. So
people probably want to break.
yeah, so the representation method, let me go ahead and cover that here really quickly before I don't want us to run out of time. So representation method that's the all right. So currently right now, if I go to print my dog, let me just comment out this my dog too there. You'll see Apollo is a brown GSD, not is nested, right? But if I nest Apollo within a parent data structure, so now Apollo is inside of a list. When I go to print it, I get Apollo is nested. So the representation method will get triggered if it is within a nested data structure. If I were to take away the representation method and then run it, I would actually get the memory address because the string method is never triggered. Does that answer your question?
I'm sorry, one more time. I got distracted very, very, very quickly.
Oh, okay.
I'm so sorry.
So string method is only triggered if you're calling the class itself or the variable that's holding the class, right? So excuse me, the class instance. So if I do print my dog, because it's calling directly the class instance, it triggers the string method. But if I were to put it within a parent data structure, like a list, then it would trigger the representation method and not the string
Okay,
method.
so representation works for nested data structure, and that works when it's a nested data structure. I don't know how else to say it. Cool, cool.
All right, awesome. Let me go ahead and stop our recording here. All right. Now, for part two of our lecture, we're going to be talking about getters and setters. Now, what are getters and setters? Well, they're utilized, or a getter is utilized to specify how someone can access an attribute. And a setter is utilized to specify how someone can change a value of an attribute. They're just essentially rule sets where you want to make sure that specific conditions are met before information or attributes, properties that belong to a class are changed. Now we're going to dive into decorators quickly just to see what's happening under the hood of a decorator. But know that a decorator is essentially just a function that takes in a function so that it can have some under the hood behavior, not under the hood. It's a function that takes in a function in order to, I guess, have quick access to this functionality or to have quick access to that behavior. We'll go ahead and take a look at what that looks like here shortly. All right. Let's dive into decorators first. And for this, I'm going to actually make a completely separate script. Don't want to make our code too messy here. All right. So starting up with decorators, it's a function that takes in a function. So here we go. You can call it my decorator, which, as we mentioned, it is going to be a function that takes in a function. And then we're going to give it a wrapper. It doesn't have to be named wrapper. It could be named whatever I would like it to do. Now, at the end of this function, or during this function, I could specify things that I want to happen before and after. So before func call from wrapper. I could actually call the function that's being passed in. And then I could print after function call. Finally, to kill the function, well, I would just return wrapper. So my decorator is returning the wrapper function. But now let's make something else here. I'm going to create or define a separate function that will just simply say hello. And this is just going to print out hello. Pretty simple. If I go to execute or call the function, say hello, on my terminal, I'll simply see hello being printed out. Well, I just created this decorator that I can utilize. So I can call a decorator by using the @ sign. So I can say at my decorator and then follow with my own Pythonic function. Well, what's happening here? Let me go ahead and execute this. Well, we can see a clear difference there. We had hello, which was when I called it without the decorator. And when I called it with the decorator, well, what happens is I call the function, say hello, but it knows that it belongs to a parental decoration. Say hello gets passed in to the decorator. The wrapper function is triggered. So we get this before function call. We then get the function, which is printing say hello. And then finally we get the call after the function. Now this is a very basic decorator. There are many built-in decorators in Python. This is just to shine the light as to, hey, this decorator isn't magical. They have functionality happening under the hood that you can look up within Python documentation. All right, Daniel.
So if we're building our own decorator, would it mostly be used for like sorting information or filtering information prior to passing it to the function? And then like, can we pass information from the decorator into the function? Like say define or say hello could take an input of like your name, right?
Mhm.
And then it would print like your name, hello, your name. Is there a way to inside the wrapper pass in information into your function at that point?
Absolutely. Yeah, so I can just pass in something like Cisco. And when doing so, you can see we get the before function call, the function being called, and then the after function called. And yes, decorators are used to not necessarily store, but more manage behavior prior to the newly established function, and then manage behavior post the function execution.
So basically, if we wanted to take data, break it down into something that our function can handle, and then take the output of our function and put it back into that big data stream.
You can, yeah, that would be a very good use for a decorator, right? Because every single time that decorator gets triggered, it knows exactly what to do prior to and what to do post the execution of the function.
Thank you.
All right. Alex?
So I'm confused about what return wrapper does.
Got it. So return wrapper, that's essentially doing, when you call this decorator, it's actually executing. It's doing the function call here on line 8, right? And what we're returning to this decorator is we are returning the wrapper. So the wrapper is then executed, right? The wrapper executes that print before. Here we're executing that function, and then it executes the post portion. So this @ sign calls the return function. So the equivalent of it would be as if I was calling the wrapper as such. Does that answer your question, Alex?
Yes, thank you.
All right. Any other questions?
For that at my decorator, how sensitive is that? I know it needs to go above that function, but if there's like a space in it, is it like, reading code by code or line by line in the code, or does
Yeah.
it need to be on top of it?
Let's check it out. So once we utilize the at decorator, it's not going to read any of the black space. And that very next line of identifiable code that it sees is what it's going to feed into the decorator. Does that answer your question, Doc?
Yeah, nice. Yeah, that's perfect.
All right. Okay, perfect. Thank you so much, everyone. Now that we know how what decorators are and how they work, let's start talking about how we're going to utilize that within our class. Well, in our class of dog, we have a couple of different property values here. We have name, color, breed, and so on. And maybe we want to be able to change a dog's name. I wouldn't really change color or breed. So I could just say that these things will never change, right? I can say, hey, these are attributes or properties, excuse me, that will never change. So these are things that will never change and that will only be set one time. Well, there's got to be a way that I can let other developers know not to touch them. So what we're talking about here is privatizing properties. Now, in Python, there's no such thing as an actual private property. If you look it up and you ask ChatGPT, it's going to give you different variations of it, but you can always access the variable and still change the value, or excuse me, access the property name and still change the value, regardless of how many underscores you put in front of it, right? Now I'm prefacing that because in previous times that this lecture has been taught, it gets brought up a lot that, oh, well, this documentation says this documentation says otherwise. Please note the standard behavior for Python developers is if you want to privatize a variable, all you simply need to do is add an underscore in front of it. And by adding this underscore in front of it, it's not changing my ability to interact with these values. But now, for other developers, when they're working within your code base, if they see that underscore, they know, oh, that's not something I'm supposed to interact with or touch. All right. Does anyone have any questions about that?
Is that kind of like using the all caps for a constant?
Essentially, right? I'm so sorry. Could you go further into your explanation? Give me some
Sorry,
time to
more
chew.
like a more like a just like a flag, just letting them know. Like it's not affecting anything, just letting them know, hey, don't change this.
Exactly. Right. This is just essentially just an announcement to other developers saying, hey, this don't touch it. There's a specific way that you're supposed to interact with this property, and it's not supposed to be directly. Well, if it's not supposed to be directly, how do I interact with this property? Because here on line 31, I'm accessing it directly. Well, that's where getters come in. So now I can specify a getter by saying at property. And what that decorator does is it turns the following method into a class property. So let's talk about that. Here, I'm going to go ahead and just simply get name, or excuse me, get color. And all this property is going to do is return self dot underscore color. Well, now how do I call this property? I can do so by calling get color. Well, wait a minute. I have the define keyword there, and I have an open and close parentheses with a return statement. So everything about this syntax is telling me that this is a function call. But I'm not calling a function there on line 35. Well, why? Well, that's because the app property, right? This app property decorator, what it's saying is, hey, this is not a function. This is going to be established as if we were creating a new variable here called self.getColor. that would return to us the color value, or self dot underscore color. Let me execute this line of code here. We are printing my dog here at the bottom. Let me take it out from the wrap data structure. And now you can see Apollo is a brown GSD. Well, everything worked. I called that get color function and everything worked exactly how I wanted to. All right, I see a hand up. Go ahead, Nick.
What happens if you comment out line 31?
Line 31, let me find it. Yeah. So if I comment out line 31, this is no longer a property. You can see that it gets highlighted in yellow, meaning that it is now a function. And if I try to execute my code, I get, hey, there is a bound method in here.
So
Okay,
would you
well,
have
this
to put
is, go ahead.
parentheses at the end of get color?
Yeah, because now it's a method that has
Okay.
to be executed to return a return value.
And
All
then
right.
is the at property a keyword, or could you put anything there?
No, this app property is a keyword.
Okay.
All right. So now that we've gone through the process of building a getter for this color, can I get some help building a getter for a breed? And this one, I'm going to go ahead and pass it on to Regino.
So in this instance, we would create a new line here, do the @ symbol. And quick question on this. So up there, you named it property. Could I name it the same thing, or could it be any name we want?
It will always be property. It's a keyword. Yes.
Got it. Okay. So then we would again assign it as property.
All right.
And I suppose we'd essentially do the same thing. So we'd define our function. In this case, we're doing the breed, correct?
Yes.
Okay, so we'd say get underscore breed. And then we'd throw in the self argument. And then we would return self dot underscore breed.
All
And
right.
then, oh, go ahead.
Thank you so much. Appreciate it. So now that we were able to build this getter, how would I call this getter within line 40? And I'm going to go ahead and pass that to Alex.
Self dot get underscore breed.
Self dot get underscore breed. Nice. Does it need opening and closing parentheses?
No.
Awesome. And why doesn't it need opening and closing parentheses there, Michael?
Because you because you use the at property above it.
Yeah, meaning that it's no longer a method, it is a property. And when we execute it, everything works great. All right, perfect. So far we've gone over getters. But Nick's question brings up a very good point. If all I need to do is change this by commenting out property, and then I could have a function call, then what's the whole point of building a getter and this extra syntax? Well, let's talk about that when we're addressing the name value here. All right. So here I'm going to create a property. And I'm going to call it get name. That's going to take in self, and it's going to return self.name. Nothing crazy just yet. Oh, and I apologize. Let me go ahead and make sure that I'm telling other developers that this is going to be privatized, right? That they're not supposed to touch this. All right. Well, what about setting a name? Because this is something that can actually change, but I only want it to be changed in a specific format. I want to make sure that all of it is alphabetical, and I want to make sure that it gets placed as a title format. Well, now let's just create that function that we use. All right, let's call this set name. This takes in self and a new name. All right, so now I'm going to say if new name dot is alpha. And let me actually specify to this function that this is going to be a string. Okay, let's make sure that's correct. Yep. So is alpha and new name dot title is equal to new name. Only then will I assign self dot underscore name to be equal to the new name. Otherwise, or I could just simply return none. And I can raise an exception if somebody tries to use this incorrectly that tells them, hey, your name is not in the correct format. So there I've built a new method to be able to interact with this name portion. Well, now, how do I actually turn this into a property that I can utilize? Well, I use my decorator symbol again, but in this case, instead of calling property, I am going to call get name. And I'm going to specify that this is the setter for the name. It ties them together. They're both working within the same property there of dot name. We know that it's a property, and we know that this is a setter. We're going to naming conventions here shortly. But for now, I'm going to break this down here. Right? So now, when I go into actually creating my dog, or if I wanted to change anything about my dog, let's say get name, right? So there I'm printing my dog name. And now I can say my dog dot set name be equal to, let's say, I can't think of a name. Let's go with Tank. Why not? And see what that does. Well, that raises an exception that tells me, hey, your name is in the incorrect format. All right, if I do something that isn't completely numeric, or excuse me, that isn't completely alpha, and I include a number, it still tells me, hey, your name is not in the correct format. Well, now if I change it as such, and I go to execute line 71, you'll see that my name was successfully changed. So now there's a rule set. There's a specific way to interact with this property of name. All right, at this point, does anyone have any questions over anything that I've covered? Go ahead, Carlos.
So I think, sorry, I was a little confused in the beginning at first because you did the dot title. So that's just basically converting it to title case, right? And then
Correct.
comparing it to, okay, all right. Yeah, that all clicked at the end.
All right, Cody.
And creating these getters and setters with the whatever, I can't remember what it's called, declaration, is only because you set the underscore and set that variable to private, right?
With decorators, yes, it's because it's
Decorators.
private. So I'm making sure that there's a specific way of grabbing the attribute and a specific way of returning its value.
So without the declarators, with the underscore, you wouldn't be able to grab it, right?
You could still grab it. You're just not supposed to. Now, that behavior is only in Python. If you utilize any other language that is OOP oriented, like C# or C++ or even Java, they actually have privatizable variable or privatizable properties that you can't interact with once they're created. So that's why the concept of getters and setters are so important. It's because the other languages will require you to be able to write those and know how to use them. Keegan?
Could you scroll up? I just want to read your code one more time.
All right.
That's
All right. Of course. Now, let's finish up wrapping up this entire process, right? Now, this part might be a little bit of uh of a detangling. So we're gonna do it a couple of times just to make sure that we truly understand what's happening here. Now I have my getter and my setter. But if I go and create Apollo with just a lowercase letter when I first create it, we can see that Apollo is created without the correct format. So what's the whole point? Why am I even making these getters and setters if the rule set that I have created is not being applied correctly?
If
Well,
it can show if somebody's messed with the data, if somebody's reset it. So if you initialize all with lowercase names, then you can tell if somebody's changed the name because it would have to be a capital first letter.
yeah, that's a great thing to that's a great point to bring up, right? But I do want my setters and my getters to actually be triggered when I go into creating a new dog.
Do you have to incorporate them into the init method?
Yeah, so I would have to throw them inside of my init method. Now this is why I said there's gonna be a little bit of unraveling, everybody. So let's start off with the setter portion, right? My setter, remember this portion, it can either overwrite an existing property, which in this case the property is name. But this assignment means that we can also create. So we can overwrite or create a property. And in this case, the property is underscore name. So what we're going to do is we're going to change the naming conventions here. I am going to change this to name. Excuse me. In line 39. So now when someone calls name directly, that is going to create this underscore name. So let me break it down before I actually execute the code here. So now in my init method, when I go to create a dog, name gets passed into the init method. After name gets passed into the init method, it is utilized here. Now this self.name, what is that doing? Can anyone take a guess as to what's happening here on line 28? The self.name equal sign portion.
It's going to call your function name.
Yeah, so this is actually going into my setter.
So it's going to pass the name into there, do whatever's in
Exactly.
your code right there, and then okay.
Yeah, so that would pass in name as the new name parameter. It would test if the name is alpha in the title and actually apply our setter. So now let's come all the way down at the bottom of our script. Oh, excuse me. Change that. We can still get name. And let's see what happens with the polo when we try to create it. Well, now I get an error. And it's telling me that Apollo does not meet the requirements and it's in the incorrect format. All right. Awesome. So now my rule set is actually being applied. So I could just change this back to Apollo. So Apollo's being created correctly because it's passing in the correct input with my setter. And now let's take it a step further. Well, I utilize this app property and I'm naming things different. I'm naming my variables differently. This get name and the setter for the name What this allows me to do is to have two methods that are named exactly the same. So for example, instead of get name, now I could just call it name. So when name is being assigned, it will call the setter. And when name is being referenced to, it will call our getter. So now you can see self.name down below, and we could change this to, instead of get name, be named name. You'll see that our entire script works exactly the same, but the behavior is different. All right. So we break it down over here for getters and setters one more time. Class becomes initialized. Name gets passed into our method because we are assigning. So that's what triggers the setter. It meets all of the requirements for our setter. So now a new property is introduced, which is self._name. We didn't create it in the initializer, but now it exists. Right? After line 42, the very first time that it is called, then line 32 comes into existence. All right, so those two are tied together. And now anytime somebody wants to access the property name, we're just simply going to return self.name. So now the variable is privatized. The property is privatized. And developers now have a specific way to interact with name without having to do this whole get_name portion. Right? And we could apply the same behavior down below. We can remove this get portion. And just return the color and breed. Let me go ahead and execute this one more time, and then I'll open it up for questions, everyone. I apologize. All right, and we can see everything worked. Apollo gets set. We have the ability to change his name into Tink, and then we see our dog too, with his string method being able to work properly. All right, Justin, let's hear it. If you're speaking, you're muted.
Could you scroll back up to line 28? So after the new line is created on line 32, after that's created, is the self.name equals like whatever your initial name was? Is that just sitting there in memory somewhere forever as your initial name that you called it before you made any changes?
Okay, so this part, is this what you're asking?
Does that still exist after the new line 32 is created and it just sits there as the name that you set it as when you initialized it, even after changing self._name later on?
Yeah, so self.name exists within memory because self.name is referencing to both of these.
Right. And if you were to create this object, if you're going to create this dog and name him Fido initially, and then later on someone's like, actually, I want to change um, self I want to change his name to like Paul or something. Like, you'd still be able to access Fido through that initialization?
Yes.
Okay, but Paul would be his new name, and that would be what would happen if you used a getter to find out his name.
Right. So
Is this making sense?
Fido would essentially leave, right? Because the original name was. So let me just break this
Because
one
now
down.
he has two different name attributes is what's confusing me right here.
Got it. So Apollo gets this name attribute that you're seeing right up here
Yeah.
is
Does it
referencing to the
just
getter and setter.
okay, now it references and it sends that over to the new attribute.
Right.
Okay,
So
or it creates a new attribute through them, but this is just to access the getter. Okay. That makes sense to me. Thank you.
of course. All right, Cody.
So during this, like during the init process, it'll look for any getter with the dot name be first, then, right?
I apologize, Cody. Could you say that one more time?
So self dot name, if you didn't have a getter or a setter, it would just take in what was inputted when at the very bottom when you initialized it.
Then it would just turn into a property. Yes. If I didn't
But
have a getter
so
and setter.
yeah, so but we did set a getter and setter. So does it during the init, it looks down through your code and looks for a getter and setter first?
Got it. That's okay. Awesome. That's a great question. Yeah. So essentially, what's happening here to put it in short terms, yes. And to answer the question, it calls self. It takes a look at the entirety of the class and says, hey, is there something called name that is part of the class instance? It then finds both the getter and a setter. So this is no longer a creation. So not create. Instead, it's an assignment or an overwrite of the original value. Let me put this in a place that's readable. Oh, where did you go? All right. Hopefully that's readable. I apologize to everyone if that isn't. So this is not an assignment. This is not creating self.name. It's changing the value, right? And then afterwards, once it goes through the setter, then it creates self.name to belong to the class instance. Does that answer your question, Cody? Perfect. I see the thumbs up. All right. Any other questions? Perfect. If there aren't any other questions, before we close the book here, let's go ahead and get some practical application as a class and build a class for a person. Now, for this person, a person should have a name, height, weight, one. Let's just keep it with those three separate properties there. How do I go about creating this person? All right, let me kick it off here. Let's get the first line of code from Dallas.
Also, the class first, you mean? Class, person, or whatever. That's technically the first line. Do you want more than that?
That's you're not wrong. All right, let me go ahead and pass it on.
I can do one more line.
All right, let's get one more then.
Okay. So then define init, so underscore init underscore parentheses self comma and then the other stuff you had listed there, name, height, weight, and colon after the parentheses down to well, is that enough for you?
That's perfect.
Okay.
Awesome. I'll pass it on from here. All right, Jay, what would be next? How do I assign all of these properties that are being passed into my init method to actually become properties of an instance?
Yeah, so we're gonna have self.name equals name. And we have the exact same thing for height and weight.
All right. And then let's actually create a new one here. Let's do on diet. And let's make that false. All right. We'll get to that on diet later. Okay, perfect. Now I want this person to be able to eat and exercise. How could I create both of those methods? And let me go ahead and pass this portion onto Andy.
Okay, so we're going to be creating methods, so separate functions for define, eat, parentheses, yeah, colon. I guess eat would be maybe, I don't know. If we're gonna return something, we probably want to put in the parentheses like self, comma, item, and then yeah, return. Uh, okay, so that would be self dot name, I think. Yeah, okay, yeah. Interpolation, is that what it's called? Or is it
Yes.
yeah. Self dot name, yeah, eats item. Really waste, yeah.
Perfect. And then for exercising, let's go ahead and pass that on to timer.
And then you would want to do another function like def exercise, self, um, I guess you could call it workout. And then you're going to return the, you're going to do self.name, and then completed, um, completed workout.
Okay, perfect. So now I've been able to create a class that has 4 different attributes, right? Now let's go ahead and create a getter, or excuse me, a getter and a setter for weight. And what I would like to do is I want to check if the weight is lower than the current weight, the person must be on a diet. How do we make a getter and a setter that would affect this weight? Let me go ahead and pass the getter portion to Dominic.
All right. For the getter, uh, go, is that the property one, right? Add
So,
property, define self dot weight.
so define weight.
Oh yeah, yeah. Um, then that's just gonna return the self dot weight.
Hold on. We're gonna put this underscore because this is gonna be privatized, right? Okay, great. Now what about the setter? Let me pass the setter portion to Aaron.
So to start the setter, it would be at weight dot setter. Next line would be define weight, parentheses, you're going to pass in self, and do you need to pass in anything else for that?
Yes, you do, because it's gonna assign, so you need to know
So like
what's
the
gonna
new
be
name
the input.
or the new weight, yeah. Sure. And then you can throw an if statement in there. So if whatever the thing you wrote above is, if the weight is, um, yeah, if self underscore weight, the privatized weight is above whatever certain mark on a diet becomes true.
I think what we said was, oh, hello. Yeah, we said if the weight is lower than the current weight, the person must be on a diet.
Oh, gotcha. Gotcha. So if the
Okay.
new weight is less than current weight, then on a diet becomes true.
Okay. Then all right. And then how do we still do the assignment?
Yeah, because that becomes the new weight, doesn't it?
So underscore weight
Yeah.
is equal to
Equals, yeah, new weight.
all right. Awesome. So now we've created a couple of getters and setters. There is one thing that I would like to bring up here. This would essentially bring up an error since the first time you initialize it, underscore weight wouldn't exist. So to fix that, we could do if self dot weight. Oh, keyboards. Sorry about that. So if self dot weight and self dot weight is underscore the new weight, then we could return the information. All right. Go ahead, Andy.
Is the property at property, is that considered as the getter?
This is our getter. Yes.
Okay, all right, yeah. Just the setter very is obvious. That's what I was wondering.
Got
Thank you.
it. Yeah, this is more explicit while this is implicit.
Okay.
All right. Go ahead, Dallas.
What you just put there for if self dot underscore weight, why do you have to put that there and have the and?
So this portion here, the very first time that I create a new person, right? Self dot underscore weight doesn't exist until line 22. Right? It's not up here. So this would return an error because I would be trying to reference something that doesn't exist. So this first if statement is to make sure, hey, if this exists, then run this logic. Otherwise, just create it for the very first time. Does that answer your question, Dallas?
Okay, now it does, yeah.
All right, perfect. Keegan?
I'm just trying to talk myself through this. So underscore weight doesn't exist at all until we call the getter function, correct?
The setter function.
So if we initialize an object, we set weight equals weight. I'm just trying to see how that underscore weight is part of this.
Got it.
What? Never mind.
So when we go to pass it in to this portion here, remember this equal sign means that we are assigning. So that triggers the setter. So equal sign triggers setter. Now that the set
Just to follow up to that, it only triggers the setter because the property is there, right? Add property.
that
Or
triggers
get
the setter because of this portion. The naming convention is weight. So that's what we're calling. Right? So
Right.
it's going into self, looking at the entirety of the class, and finding that we have something named weight.
Would it be correct to say that the first time it's initializing self.weight, it looks for a setter, and then on subsequent ones, oh no, never mind.
No, it would always be utilizing a setter. Yeah. So here, let me go ahead and rise the error first. So let me take off this portion here. This
Can we get a
first if
flow chart
statement.
of this?
A flow chart. All right. Yes, absolutely. All right. Flow chart. Let me, I'll make, let me make, let me go through this portion first. All right. So new person is equal to a person that has a name. Let's just go a height. Let's just go with uh, 5. It has a weight of, let's say, 205. All right. Now, when I go to print new person name, this is going to raise an error. Oh. And this is raising the error, and it tells me, hey, the error here is that you're calling something underscore weight, but it doesn't exist yet. Let's take a look at what happens. In regards to weight. All right, so first we have the initialization. Now, after the initialization, what we get to is it gets passed to the setter.
Why does it know to go to the setter and not the getter if they have the same name?
So let me get to that here shortly. All right. So weight gets passed into the initialization. All right. The initialization looks through the class and attempts to find naming conventions or matching. Yeah, that's what I should say. Matching naming conventions. So in this case, the one I found is a getter and a setter that are named. But both a getter and a setter are named weight. Well, how does it know which one to go to? Does it go to a getter or does it go to a setter? Well, because it found an equal sign, meaning that it was an assignment, it goes to the setter. Then inside of the setter, we create the variable of underscore weight. Let me just some self dot underscore weight. And the getter only returns the value of self dot underscore weight. And I guess how do I symbolize this? So this is only to grab oh, what just happened? It looks like I just lost some stuff. No biggie.
You got some undo buttons there you might be able to use.
It looks like it was actual lag in memory on the platform, not something that I could just undo. I tried it. Command V self dot underscore.
Is the process up there with the setter and self underscore weight, is that still called assigning? Or is that where it's changing?
No, that's still assigning,
Okay.
right? Within the setter. And black. There you go. So this one is grabbing and only grabbing. So maybe instead of doing this arrow, I could do something like this. And this one is doing assignment, meaning it's creating. All right, so we're to follow this floor chart with our weight here. So the weight gets passed into the initializer. All right, the initializer attempts to find something called weight. So here we pass it, self.weight. Well, what is self.weight? I have two different methods named weight that it was able to find. It was able to find weight, which is a property, and weight, which is a setter. Well, which one do I use? Now we know it was able to find it. And now it's to the point where it's like, well, which one of these two am I going to trigger? Well, there's an equal sign here. So because there's an equal sign, I'm going to move to the setter portion. And when I pass it down to the setter, we can see in line 22 that self._weight becomes created.
Does it know the setter because of the keyword dot setter? Is that a keyword or no?
Yes, that is a keyword.
Okay.
So that belongs to the property of weight.
So if that didn't say setter there, it wouldn't know what to do necessarily.
Exactly.
Or would okay.
All right, Daniel.
So I guess my confusion is on your if statement, if the self.weight is less than the new weight, diet would be true. Would it be the opposite? Because self.weight would be your old weight, and then your new weight that would be being passed in be less than that for the diet to be true if you're trying to lose weight.
Oh yeah, I got those backwards, my bad.
Yeah,
You
I
could
was just
be,
like us trying to like
What if you're
figure it out, and
bulking?
I'm like,
yeah, I was gonna say you could be on a diet for bulking. All right. Go ahead, Keegan.
So is this just an instance of abstraction where we see the underscore dot weight? We don't see it created on our IDE, but it's being created in the background, and then we can access it. Is that what this is?
Yes, this is a form of abstraction, right? We are creating rule sets and logic and complexity to things, but they're not something that whoever's interacting with this class is going to have to write by hand. It's hidden for them, so they can just go into using the getters and setters that we have already built for them. Does that answer your question, Keegan?
I think so. Thank you.
Of course. All right. So now that we know how this flow works, now to answer the original question as to why this is causing a failure, well, that's because self._weight, again, doesn't exist in the first initialization until we get to this final step here. All right, so that step is where it exists. But within the setter, we're trying to call it before the assignment in line 22. So the way we fix that is we check if it exists. So if self._weight exists and self._weight is greater than the new weight, then we would change the type. All right. Any other questions regarding anything that we covered today? Making classes, getters and setters, instance methods, and instance properties. Go ahead, Daniel.
I just want to make sure I'm on thinking the right way. For that if statement, when you just put in just that name, if it doesn't exist, it's just going to return false, correct? And that's why it skips that if statement. I just want to make sure that I'm like logically thinking.
Yes, if it doesn't exist, then it was just evaluated to false.
All right, thank you.
And let me make sure. Oh, this. Oh, interesting. That actually did not. It returned an error as well.
I think it's probably because it's trying to do both self.weight and self.weight is greater than new weight. Maybe if you nest the second if within the self.weight is greater than new weight within the first if statement, because then it
Okay.
wouldn't run that code until it exists.
Check. Is that what you're saying, or you're saying different?
No, I'm saying like have an if statement inside of an if statement, and then the
Hmm.
first one checks to see if it exists, and then if it exists, try to compare it with something else. Because right now it's trying to compare it with something else and seeing if it exists on the same line. You know what I'm saying?
I see what you're saying. All right, so let me fix this.
Didn't it just work a little bit ago? The other way?
I'm not sure actually. Let me run this. Now it looks like that self dot underscore weight is calling an error altogether.
Okay.
Because you haven't established weight yet. Weight doesn't have a value.
Yeah, so this doesn't exist. So I'll need to
I thought
figure
I
it out
thought to get the weight, you
syntactically.
had to call the weight on the getter.
Nope, not try. I don't want to confuse everybody. So let me let
So why don't you
me
put the line 23 above the if statement?
give me a second.
Because
Wouldn't you want to in the actual oh wait, never mind.
There you go. So it has attribute. And then I want to specify the person and then the name as a string. There you go. All right. So what we're doing here is we're asking, hey, does the class person actually have an attribute? So let me go ahead and isolate that like we had before. So does this person actually have an attribute named weight? If so, then I want to check if the weight is greater than the new weight. If so, we'll change that. Otherwise, we will assign it. And if we go into changes in this as well, we could say new person dot weight is equal to 198. And we can still print new person dot weight. Right, so there we can see 205 and 198. All right. Questions one back up. Carlos, hit it.
All right, so the fact that still assigned to 188 is kind of throwing me off because so person itself is the class person is never going to have that attribute because you're not adding that attribute to the class, you're adding it to the instance. So why is the person dot has attribute uh changing even though you're assigning the it's not the person class that's getting the
Yeah,
yeah.
that's a good point. Yeah, so we could change it to self, and self would work at the end of this.
Because
How
then
do I
like let's
explain
say
it?
were to make another person
That
or
person wouldn't have the attribute. Yeah, I get what you mean. So, for example, if I were to do person 2 or 12, I guess, and then I try to run it, I'm trying to think on how to demonstrate it.
I think right now what that if statement is to assign the diet. So can we print the diet whether or not it's true or false?
Yeah, absolutely. All right, so there you can see false for both of them, and that's because we're referencing new person 12. If I reference just the person itself, you'll see one of them being false and then the other one being true. So everything's maintaining and staying isolated to that one person. So just for readability purposes, self would be the correct object that we're comparing here. That's a good catch. Thank you,
Okay,
Carlos.
sorry. Can we actually instead of assigning or basically creating a new person, so on new person, just change the weight to something that will cause it to go on a diet. So for new person, just do the setter for instead of 205, make it for 198. Because then
Okay.
that would change the flag for on diet to true, correct? That
Right.
should.
So that's what we
Okay.
saw. Yeah. We see it here in false the first time. That's from 34. Then we assign it to 198, and that's what changes it to true.
Okay, I think it makes sense now. Thank you.
Okay, awesome. Timer?
So going back to when like the problem that you were running into with the setter and like not having the initial value, why wouldn't you set in the constructor self dot underscore weight instead of self dot weight?
Yeah, that's a great question. So when it comes as to why is it preferred to keep it away from the initializer, like why go through this trouble of even possibly running into an issue like this? Well, when I do it this way, right, we want to have some sort of abstraction, like we were mentioning before. It takes away from the developer even the knowledge, or it helps take away the knowledge that there is such a thing or other people interacting with this class as self underscore weight that exists in it. I know it exists. And if somebody takes a look at the fine code, they would find out that it exists because they would see it here. And they would see that the property is being established and that there's a getter and setter. But for someone who's using this program maybe as an extension, maybe I created some sort of package that they can just download easily and they want to work on it, they would never even know that there is an underscore weight that exists. By default, they would always just call that dot weight and run into my getters and setters, which is the goal that we're trying to accomplish here.
Okay, got you. Thanks.
Of course. All right. Any other questions? Perfect. If there aren't any other questions before we close the loop for the class, a question was asked, I believe, on Thursday regarding JavaScript, either Thursday or Friday, probably Friday, regarding JavaScript as far as it being an object-oriented programming. So it does support OP. It is an object-oriented programming program, an object-oriented programming program. Just note that it relies on objects, not classes. And here, I've provided a little bit of sample code that looks almost exactly the same as our Pythonic code. So let me bring that up side by side. So there we have our class of dog. Although this says class is actually just creating an object, not a class. Here we can see the constructor for both of them. In JavaScript, it's called a constructor. In Python, we have an initializer. We have our property getters and our property setters. Here's my string method inside of JavaScript. Here's my string method inside of Python. And then I have my instance methods, such as speak and fetch. Notice that instead of utilizing self, JavaScript utilizes this. And when it goes to creating a new instance, you call new to be able to create a new instance of the class. And to see the string method, you actually have to typecast it into a string. All right, so everything that we did today in Python can be done in JavaScript, and I strongly encourage for everyone to go the extra mile. And after they're finished with today's assignments, do them again in JavaScript, just so that you have both languages under your belt. All right, I'm going to go ahead and stop our recording here, everyone.